So now I'm going to draw a ray diagram for a diverging lens. So I've marked the midpoint, I've marked the two focal points, one on each side, and then I've drawn the object here. We need to draw our lines through here. So the first one, I always think the easiest one is to go through the middle, and I always like to start with easy. So first I'm going to draw the midpoint line. So that goes through just like that. All right, so that's the midpoint, the M line that goes through there. That one's easy. All right, next one. To me, it's easiest to think about the light that went in parallel, because I can kind of see that. We saw it on the board. So the light that comes in parallel to the principal axis hits the top here and then diverges. So it goes out and it goes directly away from this focal point. So from this point, it goes directly away from F, okay? I can see that this line and this line are not going to cross. So I know I'm going to have to put in the virtual line going backwards from that one. So the real light goes this way, but I can draw my dotted line backwards to make, it's going to have to be a virtual image. And I can see already that my object is going to have to be right here. That's what the two that I find easiest to draw most of the time. Now, if you can't draw that one, then there's the one where the light, if it comes parallel to the principal axis from this direction, it will go directly away from the F here. So coming in parallel, we'll go straight away from the F. So we do it backwards by drawing a line straight toward the F from this side until it hits the mirror. So, or sorry, the lens. So straight in this way, and then it would go parallel. Okay? But again, this line is not going to intersect with these other ones. So I do dotted line back and gets reasonably close to the same spot for that, that image. So I know the image is here. So the image is reduced, but still upright. And since I had to use the dotted lines going backwards from the lens, I know that it's a virtual image. Okay, now it's time to see if our math works for a diverging lens and making an image with a diverging lens. This is the exact same board that I just drew. I've added in a few bits of information. I changed the scale on it just for fun. So these used to be 0.1 meters between each one. Now I've made them 1 meter. So the focal distance, so focal length right here from the middle point to the F, that's 2 of them, so 2 meters. And notice I put -2 meters. This is a diverging lens, so the convention is that the focal length is negative. So focal length -2 meters. Distance to the object, 1, 2, 3, 4, so 4 meters. And the height of the object, 1, 2, 2 meters. Same question, find the height of the image, distance to the image, magnification. So magnification, HI over HO, or minus DI over DO. And again, we don't have any information about the image, so we can't use this yet. We'll need to start with this one. So solving for the distance to the image, 1 over distance to the image is equal to 1 over F minus 1 over distance to the object. So this is 1 over -2 meters minus 1 over 4 meters. And 1 over -2 minus 1 over, so that's minus, let's see, this is -2/4 minus 1/4. That looks like -3 over 4 inverse meters. Okay, so -3 over 4 inverse meters. So that means DI is 1 over that. So -4/3 meters. And if this is 1 meter, that's a little bit more than that. So that makes sense. So 4/3, so it's in just about the right spot. So the distance, it's negative because it's on the same side of the lens as the object. So that's good. So we've got distance to the image. And now that we've got distance to the image and distance to the object, we can find the magnification. So -4/3 over 4. These are both meters, meters cancel. So minus 4 over 4 cancels, minus 1/3. Magnification minus 1/3. So however tall this was, this one should be 1/3 as high. And this number's, why is that negative? Oh, minus minus is plus. There we go. Minus minus, those cancel, so it's plus 1/3. So it's upright. So upright and about 1/3 of the size of the object, so that's good. And now we can do, we need to find height of the image. So height of the image equals m times height of the object, which is 1/3 times height of the object was 2 meters. So that's 2/3 of a meter. And that's it, we've got it all.